Ladies and gentlemen, as we continue working in geometry, we are going to look or continue to look at our rigid transformations and focus this time on our rotations and thinking of how are rotations described mathematically. And we have briefly talked about rotations as an introduction, but let's see some basic information that we need to know. We know that a rotation, a rotation is a rigid transformation that moves every point of the preimage through an angle of rotation about the center of rotation. So as we talk about this, we have this center of rotation, and everything will be moved at the same angle about that center of rotation. And the points are rotated in a given direction, either clockwise or counterclockwise about that center of rotation. And we can see here that these arrows are intended to say, if I go from my pre-image to my image, if I am traveling this direction, that is negative. And then if I go from my image to my pre-image to my image, if I'm traveling this direction, it's a positive rotation. And then, of course, here it is. An angle is positive when the rotation is counterclockwise. And again, counterclockwise is going this direction. Counter the way the hands on a clock turn. And then if the figure is rotated negative, the angle of rotation is negative. So if we start going clockwise, it would be rotated. So maybe I shouldn't have had negative there in that notes. Maybe we should say that if a figure is rotated clockwise, then the angle of rotation is negative because this direction is clockwise. And then, of course, this direction is counterclockwise, and that makes a positive angle. And then the attributes of rotation. So the distance connecting corresponding vertices to each other. Now, corresponding vertices, so this would, A would correspond to A prime. And now we're going to talk about what are some of the attributes of this. And one is that, as you can see, if I try to connect a line from the vertices of A to A prime, it goes through the center of rotation. Also, all of my lines drawn from vertice to vertice, corresponding vertices, they're not the same length. And then they are not parallel. Remember, when they were parallel and the same length, that was very common for translations. And then let's see, what I do find out is if I label, let me go ahead and label the center of rotation, and we will call the center of rotation D, that if you notice, BD is the same length as B prime D. And then all the points on the figure are going to be rotated. So everything is going to happen to have rotated the same direction for the same distance. Okay, so there are some of the attributes. Okay, and there I go. Pass through the center of rotation, are not parallel, are not congruent. And then, of course, we see we do have some congruent segments and corresponding segments. And then all positions on the figure are going to be rotated. Now, performing rotations, we have triangle EFG is rotated 120 degrees clockwise from its image, and we're going to get E prime, F prime, G prime. So what they're saying is, as I travel from E to E prime, this rotation is going to be 120 degrees. As I travel from F to F prime, it too is going to be 120 degrees. And then finally, as I go from G to G prime, it is going to be 120 degrees. And if you notice, we are going counterclockwise, so that is going to be positive measurements. Now, as we look here, rotations on the coordinate plane. Now, rotations require a center of rotation and an angle of rotation while preserving angle measures and the side lengths of figures. There you go. And for example 1, as we start to look at these characteristics, the center of rotation, as we have talked before, the center or the line of reflection that we had, if the image and the pre-image had the point in the same location, then they were on the line of reflection. Well, here, if we have a image and pre-image item on the same point, then that would be my center of rotation. So that would indicate here that my center of rotation is going to be the origin, and that of course is 0, 0, and we can tell that because we have right here that A and A prime are the same location. The angle of rotation now could be a little bit more challenging to identify, but as we go from each one of these quadrants is going to be 90 degrees. So if I started at my image or my pre-image and I rotated this direction, that is going to be 90 degrees. And it is in a counterclockwise direction, so it is a positive 90 degrees to get from here to here. And as I go around, this is going to be from this point right here of 0, I would have traveled 90 degrees to here. And then as I continued on from the axis to the next axis, that would be another 90 degrees. So this is going to be 180 degrees. And as I continue around, I just went another 90 degrees. So this is going to be 270 degrees. And then finally, I'm going to be back to 360 degrees or back to 0. So my angle of rotation, since I went from this quadrant all the way over here to this quadrant, that turns out that that's actually 90 degrees. And the pre-image, I hope that everybody at this point in time knows that the pre-image is going to be A, B, C, D, and then the new image is going to be A prime, B prime, C prime, and D prime. So simple characteristics that we're trying to identify from rotations. Now here in example number 2, we are starting with, let's see here, there's A prime, so that might be the first move. Here's A double prime, A triple prime. So it looks like we are starting here, A, B, C, and we are going to first move over here because there is my A1. So I'm going to take A and I'm going to end up over here at A1. So A1 is, in this case, A1 is going to be 4 and 1. Or negative 4, right? As we go from here, this is negative 4. And then that makes A double prime from here. That is, sorry, right here. That is going to look something like negative 1, negative 4. And then as I come around over here, we have 270 degrees, and we'll find out that that is going to be 4, negative 1, and then last but not least, as I carry it back to the home stretch, this would be just returning it back to its normal, which would be 360 degrees, and therefore it is going to be A prime is equal to, I'm sorry, it is equal to 1-4. And if you'll notice, we started off with A, which was going to be, let's see here, it was going to be 1, 4. As we went 90 degrees, what happened? It looks like my Y value and my X value changed, but my Y value also became negative. So you see, it used to be XY, now it's XY, and those two values have changed, but instead of being -4, it's now +4. And let's see, what else do we know? Okay, that would be the rule there when I go 90 degrees. When it's 180 degrees, well, that would be over here. So I went from 0 to 180 degrees. And then this is going to be where, I'm sorry, I went from this 0 to 90, and then 90 to 180. So I am looking at to identify this point right here, which is going to be, as we said, -1, -4, right there. And what happened? It looks like -1 was my original. X is the same, but is going to be a different sign. And then Y is going to be the same, but also a different number. I'm sorry, a different sign. Let's see, what happened is we went to 270. So we started here and we went 90, 180, and 270. So it looks like I am going to have, right here, I'm going to have, it looks to me like I have 4, -1, which is going to be the opposites, because it is 1, 4 starting off. So the opposite, 4, -1, and therefore we end up having a negative y, I think, or -x. And then finally, if we go 360, then we know that it just becomes xy, because we've gone right back to its location where we started from. And there you have it. There's looking at some of those values and coming up with the information you need. And again, just to address our mapping rules, as we rotate about the origin 90 degrees, our xy will become -yx. As you rotate about the origin 180 degrees, our xy become -x, -y. And then, of course, rotating about the origin 270 degrees, our xy maps to or becomes y -x. And of course, reflecting about the origin 360 degrees puts you right back where you started. So your xy simply becomes your xy. And there's, again, these mapping rules as we fill them in. Let's see here, looking at our next example. What rule describes the rotation about the origin from the pre-image to the image, and how many degrees about the origin was the figure rotated? Okay, let's see. Looking at this, we want to examine our pre-image and our image, of course. Here's where we started with our pre-image, QRS, and then we rotated or became our new image is going to be Q prime, R prime, S prime. So we can examine just one of our points and determine the mapping rules. And what I'm going to do is I'm going to start with R, and we're going to figure out my R value is going to be, R used to be 4, -1. And then it mapped to R prime, which is going to be -1, -4. So let's think about, what did our mapping do? Our xy mapped to, it looks like, let's see here, it looks like our old x value, right? Excuse me. Our new x value is our old y value. So that's our old y value, and it looks like our y value is our old x value, that has been negated. So this y value is 4 negated. So looks like this is going to be our mapping rule. And if we go back and we look at our mapping rules, which one is that? Well, I can tell you that we have mapped this direction 90 degrees because we went one quadrant on the coordinate plane, but we have to remember that when we go clockwise, that would be negative 90 degrees. Or we could say that we mapped 90, 180, 270 positive. So we could say minus 90 degrees, or we could say that we went positive 270 degrees, realizing that these two will put me in the same location, going back 90 or going forward 270. When I say back or forward, I just mean a positive or negative. So yeah, those are going to be the same thing. So it turns out that we are going to have rotated about the origin 270 degrees. And continuing on here, example number 4, what is the image of triangle DEF after the rotation of about the origin, rotation about the origin 270 degrees? Well, we remember the rule here, 270 degrees, so that rotating about the origin 270 degrees is going to be XY will map to, I keep doing that this morning, Y negative X. And let me clean that up some. Y negative X. So looking at our points, we can say, let's see here, I got D, I got E, I got F. I'm going to take the points, right? I got D, E, F. So it looks like D is going to be -5, +2. -5, +2. E is going to be -1, +2. And F is going to be -3, +4. And as we map to it, again, we said it is going to be Y negative X. So my D prime is going to be, my new X value is going to be my old Y value. So that is going to be a 2. And then my new Y value is going to be the opposite X. So we have -5, so it would be, I'll just show this here, -5, which will map to D prime is 2, +5. Then E prime is going to be, well, we have our, again, Y value is 2, and then we're going to have the opposite X, which would be -1, and that is going to map to E prime is going to be 2, 1. And then lastly here we have my F prime, and that is going to be, again, the new X value is the old Y value. And the old Y value is 4. The new Y value is going to be the negated X value, which is going to be -3, and then therefore we end up with F prime is going to be 4, 3. So now, did we need to do all that? I guess we did, because we want to be able to figure out what is the image. Well, we've figured out our points, so we can go ahead and plug those in. And I will say that D prime, 2, 5, 2, 1, 2, 5. So there's D prime. E prime is 2, 1, so 1, 2, 1. E prime, and then F prime is going to be 3, 4, 3. 2, 3, 4, 1, 2, 3. F prime. So there is my new image rotated 270 degrees. So we went 90 degrees, 180 degrees, 270 degrees, or we went minus 90 degrees. So there you go, that's rotating about the origin 270 degrees. Now looking here on this next example, we have example number 5. What is the pre-image of the figure if a rule that created the image is rotated about the origin minus 90? Well, remember that when we are going counterclockwise, that is a positive rotation. When we go clockwise, that is a negative rotation. So in order for this to have its original image, it must have been over in this quadrant somewhere, and it rotated that direction. So in order to find out where we came from, what that pre-image was, we're going to go ahead and reverse that, and we're going to use the 90-degree rule. And the 90-degree rule is going to be, let's see here, it should be the rotation for 90 degrees. Let's see, the rotation about the origin for 90 degrees of xy should be negative y x. So as we look here, let's go ahead and label some of our points. Q is going to be 5, 2, sorry, Q prime. S prime is going to be 2, 4. And then finally R prime is going to be negative 1, 2. So when I start here, I have Q prime is going to be 5, 2. And if I rotate that, Q is going to be, again, using my mapping rule here, negative y x. The x is going to be negative y, which would be negative 2, and the y is now going to be the old x, which is going to be 5. And let's see, when we map that, that would be negative 2 and 5 right there. That would be my Q. Clean this up some. And let's see here, the R. R prime is going to be, we said, what, negative 1, 2. That's going to map to negative 2, negative 1. So negative 2, negative 1. Wrong direction. Negative 2. Whew. Negative 2, negative 1. And that's going to be, just R. And then finally, the S prime is going to be 2, 4, and that's going to map to S, which is going to be, again, negative y is going to be my x value, so I'm going to have negative 4, and x is going to be my new y value, 2, so negative 4, 2, and when I connect those points, that is where I originated. That is my original location right there, and then I rotated negative 90 degrees and ended up at that image. So they were able to go back and calculate that pre-image. And then finally, after a rotation of 90 degrees about the origin, the coordinates of the vertices of the triangle are A prime, B prime, and C prime. What are the coordinates of the vertices of the pre-image? Okay, again, they're telling us that this was created with after a rotation of 90 degrees. So 90 degrees we would have, hypothetically, if we are right here, when we rotated 90 degrees, this would have taken us 90 degrees. So in order to get back to that location, we need to go 270 degrees, because we don't have a negative 90 degree option, but we have to know that negative 90, again, negative 90 is the same thing as going 270. So our mapping should be XY maps to, 270 degrees about the origin of my rotation is going to be, should be Y negative X. Okay, so as we do this, we can say that my A prime is 6,3, and I'm going to map that to A, which is going to be, my X value is going to be my old Y value, which is 3, and then my Y value is going to be the opposite X, which is going to be negative 6. And then B prime, not squared, B prime, is going to be negative 2, 1, and that's going to map to B, which is going to be, again, the Y value is 1, so that'd be my new X, and the X value is negative 2. Negative 2 times a negative becomes a positive 2. And then finally, C prime is going to be 1, 7, and it's going to map to C, and again, using this same mapping rule, my Y becomes my X, and my X value becomes my Y opposite, so it's going to be negative 1. So there you go. There are the vertices of my original preimage. And that is working with rotations as we go. So we'll work on our activity today, and good luck.